see, Jalen and Tyler and Mia. And Menora. All right. We are going to work some more, try and get finished up with the stuff we should have gotten finished yesterday. It didn't happen. And try and get our documents filled in too and finish the last little bit of the graphic organizer. Where did it go? There it is. So today I had hoped that you would be doing the magnesium and the burners. Not going to happen. So that's okay. We'll do this on Thursday and start practicing some balancing. And I guess on Friday, we'll finish up the lab. And so it will not be due on Friday. It'll be due next week. But yeah, things ever evolving plans around here. So we have everybody in the classroom is present and accounted for. Thank you very much. Who would like to claim that they are dressed as a teacher today?
Smith is wearing tropical stuff, and I wear tropical pants.
Oh, tropical pants. I like it. Oh, my. Okay. And Mr. McGee says he's Mr. Donut. Anybody else? What are we doing? There it is. T-shirt and shorts. Yep. All right, Luke's in with a hero point. Huh?
I can just do that.
Sure.
Oh, cool. You see the T-shirt.
Oh my. Well, at least James has got on a sporting shirt.
I have sunglasses in my car. I will do it.
Yes, sir. You got shorts and T-shirt too. Okay, Maury. Classic rock. I don't think that's one he would wear, but that's okay. I can roll. Silliness.
You know what he listens to? It could be classic rock.
Could be. You're right. I don't know his musical preferences. You are correct. Tony, welcome. All right. Yeah, it was nice having a little journey this morning. That was good. All right. I don't see Leela, and I don't see... Oh, there's Hannah. I lied. Okay. And no, Marin. All right, let's get this show on the road. We're going to add to this. So we got through combination. We got through decomposition. We got through single replacement and double replacement. What's the matter? I changed the picture. I know.
This.
What? It was just a picture.
I was admiring the art.
Oh my gosh. Is it summer yet? Not yet, huh? Weeks to go. We got this. We can do it. All right. We left off yesterday with double replacement or double displacement. And today it's out of order on the graphic organizer. So I put neutralization right after double displacement in my PowerPoint because neutralization is a special kind of double displacement, right? So that's why it's here. And I'm going to color code it because acids and bases are what neutralize. So a base can neutralize an acid can neutralize a base, however you want to think of it. Usually we say the base is neutralizing the acid. Hydrogen is what makes an acid an acid. And on litmus paper, acids will be red. So the part that makes an acid, we've already gone over this, is hydrogen. And the part that makes a base, at least most of them, is hydroxide. So type this into your Google. You can handwrite it on a piece of paper or type it into the graphic organizer, whatever makes you happy. And then remember that the hydrogen has to go with an anion in the acid, and the hydroxide has to go with a cation in the base. So you're supposed to remember that anions are negative and cations are positive. What's the charge going to be on a hydrogen? Oh, this is 2 things you should have out today also just to help you. Your ion sheet and your activity series papers. So find those right now. They're easy to find because they're colored. Does anybody need one?
I wrote it on my notes.
I'm okay with that. But they're at the top on the classwork page, but
I might need the purple one.
okay. All right, so you should know, hopefully, hydrogen is on top of the alkali metal column. It is an element that just has 1 electron, that's it, and it usually loses it, which is why it forms a positive ion. Okay, most of the time. Hydrogen can become hydride, but most of the time it's a positive hydrogen ion. Hydroxide, find hydroxide on there. What's the charge on hydroxide? Oh. Charge on a hydroxide ion. You have to look on your purple sheet. Tell your neighbor what it is. Jaden, what's the charge on hydroxide? Okay. So the polyatomic ions are up here. They're also on the back, but you have to know what their formula is. Any luck, Jaden?
Is it negative?
It is. It's a -1. Okay. So guess what? +1 and a -1 make a compound. So when we do innies and outies, right? My silly way to remember the double displacement, you get something that has the cation from the base with the anion from the acid. That is a class of compounds called a salt. It's not necessarily something you want on your food, but it is classed as salt. And then the hydrogen from the acid goes with the hydroxide from the base. Okay, we had lots of pain over this earlier today. What is HOH? H2O, which is water. Okay, so normally you'll write it H2O, of course, but I want you to recognize that there's a positive hydrogen and a negative hydroxide that go together to make water. Okay, so reactants, an acid, they have hydrogens on the front, and a base, they have hydroxides on the back. The only 2 products are water and something that is called a salt. Okay, it might be sodium chloride, it might not be. So our example is always the simplest one, the easiest one. Hydrogen chloride. Let's keep my colors coded here. Hydrogen chloride, aka hydrochloric acid, and sodium hydroxide, lye, drain cleaner, whatever, and innies and outies. So everybody look up the charge on chloride and look at the charge on sodium. Justin, what's the charge on chloride ions?
I'm sorry.
Where's your purple sheet?
Oh,
-1, absolutely. Chlorine is a halogen. It has 7 valence electrons. It wants one more. Guess what? It steals it from the hydrogen. Sodium is a what charge? All the time, never changes. Lily. Positive one, perfect. So -1, +1, all done. Guess what? NaCl, table salt. And then our HOH forms our water. Okay. On a graphic, a picture space filling diagram, here's a sodium. It's really not to proportion. Actually, I'm looking at this right now. It was bothering me this morning, but now I know why. Sodium should be a smaller atom than the chlorine, but anyway, it's colorful, so I picked it. So sodium hydroxide and hydrogen chloride makes water, okay, and then salt, like salt, sodium chloride, okay, or like our little model. Okay, last reaction. Any questions on neutralization? So on your graphics organizer, it's number 5, but it's the last one that we are going to learn, and that is combustion. Combustion reactions happen when hydrocarbons react with oxygen, and they only make 2 products. So hydrocarbons have carbon and hydrogen. God bless you. The book uses algebra variables for the subscripts because there's lots of different hydrocarbons. They also use this really, I think it's terrible. I don't know. Maybe you guys will like it. Some of you probably will. The way to figure out the coefficients in front of the oxygen, they have this weird variable thing. Now, this is combining everything everybody hates: algebra, fractions, and chemistry. So, you know, it's really annoying, but I have an easier way to do it. So just hang with me. And then X number of carbon dioxides. And this is really goofy. Y/2 H2Os. Honestly, I really don't like this, but it works. It does work, but I think there's a better way to do it. So again, the only 2 reactants are your hydrocarbon and oxygen. And of course, you're not adding oxygen. You don't have like a container of oxygen that you're sprinkling in. It's in the air in the room. Okay. So the oxygen's there. And then the only 2 things you make if you have perfect combustion should be carbon dioxide and water. Unfortunately, especially for all those poor people in Texas this past winter, carbon monoxide also forms in combustion reactions. Yeah, but we pretend it's a perfect world. Hydrocarbon, oxygen, carbon dioxide, water. That's it. How do we balance these? Well, the best way to do that is with an example. And so the example that your book has is methane, CH4, and oxygen. And again, the only 2 products always carbon dioxide, at least in chemistry balancing equations, and water. My trick for you, my suggestion to you is when you're doing combustion reactions, start with carbons and make sure they're balanced. So I have 1 carbon on the left. Remember, we're going on either side of the arrows. I have 1 carbon on the right. So that's balanced. Ka-ching. All right, we're good with carbon. Next thing, balance the hydrogens. Okay, this side has 4. This side has 2. That's not balanced, right? So what's the fastest way to make 2 into a 4? Make 2. So you need 2 of these. Pretty good so far? Okay, so now my hydrogen's taken care of. The next problem is oxygen, and oxygen's a problem all the time because when you go to the oxygen store, you have to have 2 at a time. However, they can be used one at a time in compounds. Fortunately, in this one, we have even numbers, right? We have 2 on the left and we have 4 on the right. It's when it gets to be an odd number. You have to look in 2 places for oxygen and combustion reactions because it's in carbon dioxide and in water. But we've already fixed part of the oxygen problem because we doubled the water to fix the hydrogen problem. So again, we have 1, 2, and now we have 3, 4. We have 2 on this side. So all we have to do is put a 2 here and we'll have 1, 2, 3, 4. And now our reaction is balanced for oxygen. Always do, just make yourself a little note on combustion reactions. Always do oxygen last. Start with carbon, then the hydrogen, and then the oxygen. And I'll talk to you about how to make it balance when there's an odd number, because you don't always need 2 or 4 or 6 waters. Sometimes you only need 5. All right, so lighting your burner for us is not going to be methane, it's going to be propane. And we'll do that, like I said, on Thursday. Questions on combustion? Beautiful. All right, let's end that. And I'm going to ask you to find your lab. So those of you in the classroom, get your lab papers out. Keep out the purple and the yellow sheets because we're going to look at those. And I'm going to get rid of this mess. All right. So on Friday, we put together some rocks and some 6 molar hydrochloric acid. I told you that we made calcium chloride, but I didn't go over how that happened. So the calcium and the carbonate come apart and the chlorine and the calcium go together. So why don't you take a second, where's my timer, and tell your neighbor what the charge is on calcium. Go. So your purple sheet would be the most useful, but you can tell it's in the second column. Hint, hint. John, what's the charge on calcium going to be?
+2.
+2. Awesome. Okay. And what's the charge on chloride ions? Esme. All the time, never changes. Group 17 or 7A. All the halogens. -1, absolutely. First period could not come up with that. Made me so sad. Okay, so if I put one of these together with one of these, it's not going to be 0 charge, right? So I need 2 because both of the calcium electrons have to go somewhere and they go to the chloride ions. So that's why the formula is CaCl2. And then one of the oxygens from the carbonate goes with hydrogen to make water, and the CO2 comes off as gas, which is what you put the lit splint into. God bless you. So if you look on the left, we have 2 problems. There's only 1 chlorine and there's only 1 hydrogen. On the right, there's 2 chlorines and 2 hydrogens. How are we going to fix that? Anybody? What's it called? What's the number in front called, guys? God bless you. What's that called? Wait, talk to your neighbor. Go. Tell them what's called. Figure it out. What's the red 2 called? Dominique, what's it called? No, that's the wrong answer. What's it called? Anybody? Oh my goodness. Okay, you guys are so good at Googling. Google it. Let's go. Find it. Numbers in chemical equations. What are they? What's that? No. Thank you. Here, a point for Gigi. Okay, coefficient. Need to know that word. Okay, the coefficients are multipliers, if you will, but it's instead of writing the whole thing out again. All right, so you need a coefficient of 2 in front of the HCl. Everybody got that on your papers? Everybody at home got it on their documents, I hope. The lit splint should have gone out. Could anybody tell? Was it warm, cold? Couldn't tell. Anybody? It doesn't matter which one you put. Just make sure you circle something, okay? What kind of reaction is this? Well, this is a little bit tricky, but it's a double replacement reaction. It's just a little hard to tell because it's got a gas formed, okay? So things in the front, switching with things in the back of the other one, right? So the calcium is going with the chlorine, the hydrogen's going with oxygen, but there's also gas coming off. Okay, question on that. All right. Reaction number 2 was the baking soda with the acid. This time the sodium at the front went with the chlorine at the back. So it's also a double replacement kind of reaction, plus a gas forms. Okay. And make sure you mention that the baking soda is a white solid and that the acid was a clear liquid. And what happened when you put them together? Could you tell on this one on the temperature? Anybody feel the test tubes on this end? No?
Oh, I did. It was empty.
Yeah, probably felt a little bit cooler. Again, if you didn't, just put can't tell. I should have forgot to check on here too, but. So on this one, we got 1 sodium on the left, 1 on the right. Ka-ching. Hydrogen and hydrogen. There's hydrogens in 2 different reactants. There's a hydrogen here and a hydrogen here. There's an extra oxygen from the CO2. So this ends up being balanced. Once you get the proper formulas for the compounds, it's already balanced. You don't need any coefficients on this one. And the lit split should have extinguished again. Questions on that? All right, that was Friday. And then yesterday, you put the hydrogen peroxide with the catalyst, okay? And if you are handwriting your documents, please write MnO2 over the arrow. This time, how many of you got it to relight? Some of you did, right? The glowing splint. Did anybody? Just Maury? Okay, good. Yeah, a couple of you. Good. All right, so this is one single, oops, did I put all the states in there? Yeah, I did. This is one single reactant making multiple products. So actually, this is aqueous because this hydrogen peroxide is 3% hydrogen peroxide and 97% water. So it's in water. And we made water, which is a liquid at room temperature, and oxygen gas. What's wrong with my oxygen? There's only one. How do we get oxygens? They're always in pairs. So it's always diatomic. So make sure you get a subscript of 2 on your oxygen. And then the next thing that we needed to do is balance it. So there's 2 hydrogens, 2 oxygens, 2 hydrogens, 3 oxygens. Not good. Okay, so when you look at this and you see even on one side and odd on the other, right? The hydrogens are good, 2 and 2, but there's 2 here and 3 here. The only way you get oxygens from hydrogen peroxide is 2 at a time. So you're going to have to do something to the water molecules or to the oxygen gas. Okay, turn to your neighbor, tell them what you're going to do. Go. How do you get that balanced?
Well, wasn't these supposed to put something over the arrow? Is that what you're talking about?
Nope. That doesn't get incorporated. That's a catalyst. It's not a reactant. It's not a product.
Yeah.
Talk, you guys. Oh my gosh, I'm telling you to talk and nobody talks. I don't understand. Kids these days. All right. Maury, what can we do? Two H2O2? I don't know. Which one? Or both? Yeah, maybe both. If we do this first, now we've got hydrogen, hydrogen, oxygen. So now we've got 4 hydrogens, 2 oxygens, 4 hydrogens, 4 oxygens. Four hydrogens, 4 oxygens, right? Okay. So you need a coefficient for both of them. It's a trick question, I guess. Right, so now we're balanced. That's good. What kind of reaction is this? What type of reaction, James? Something's falling apart. Yep. Thank you guys for raising your hands instead of blurting out. I appreciate that. All right. Decomposition and the glowing splint, hopefully relit. If you got to relight more than once, you can say times whatever. And did anybody notice a temperature change on this? Can't tell, that's fine. That is fine. All right. This is the zinc, solid zinc with the blue liquid. So that blue liquid is copper 2 chloride. And it was in solution, so it's in water. And when you put that onto the zinc, what happened? Did anybody get to this yesterday? Nobody did? Oh, you did? Okay. So we should let you do it. And then think about what's going on here. We have one single element and a product. Excuse me. We have for reactants, we have an element and a compound, and the products have an element and a different compound. Different element by itself, different compound. What kind of reaction is that going to be? I'll give you a hint. You need this paper. So find zinc and find copper. Who's at the top? Go ahead. It's not neutralization. It's not an acid and a base. Single element and a compound making a different element and a different compound. Oops. Single replacement. Yeah. Let's try. Okay. So if you look, zinc is higher on this list. Everybody see that? Copper is down below hydrogen. That means zinc is more active. That means zinc can copper off of the compound, even though it's in solution. And so you're going to get copper by itself, and you're going to get zinc chloride, and we'll talk more about that. And then the last one is the silver nitrate and the sodium chloride, and this is the innies and outies. Okay, it's not neutralization because they're not an acid and it's not a base, but it's innies and outies, which of course is officially double displacement. Okay. Or double replacement, either one's fine. Right? So you're going to think about how sodium goes with nitrate, how silver goes with chloride. Also on this one, you can look and see about solubilities, but we'll talk more about that later. We have just enough time for you to get the reactions done. These last two in the well plates. Remember, the zinc and the copper chloride go in the bucket, in the beaker, plastic beaker. The other stuff can go in the drain. Okay, so put on your goggles, do these experiments if you haven't done them. Those of you at home, they're in the classroom with the lab. I posted them already, so you can just look at those. Do you have any questions at home?
Was it?